Welcome to Season 9 of the Prosthetics and Orthotics Podcast. This is where we chat with experts in the field, patients who use these devices, physical therapists, and the vendors who make it all happen. Our goal? To share stories, tips, and insights that ultimately help our patients get the best possible outcomes. Tune in and join the conversation. We are thrilled you are here and hope it is the highlight of your day.
Hi, everyone. My name's Joris Peels, and this is another episode of the Prosthetics and Orthotics Podcast with Brent Wright. How you doing, Brent?
Hey, I'm doing well, Joris. And I know you're all about the seasons thing, but this is the first episode of season 9. Okay, so this is our 97th episode.
Okay, cool. I hope the residuals are good. Okay. All right, cool, man. So, hey, my burning questions, of course, is you went to Rapid. I didn't. What did you see there? What was cool?
Man, Rapid was great. Energy was high. And I actually was talking to a few people, and it was the most vendors ever in one. They had the most vendors ever, which was really cool. And there was some great machines, like I saw the Impossible Objects machine. They had that run, and that was really, really wild. Seeing that, and then I'm actually working on a project with them that I'm very excited about sharing with the world here soon. But it revolves around 3D printing rather than using pre-preg carbon fiber. So I'm super excited about that.
Oh, that's cool. Yeah, Impossible Objects is a continuous carbon fiber production technology, mostly used for aerospace and stuff like that. They've been working on this for quite a long time, actually. Very, very difficult, very, very complicated machine, but the technology has a lot of process or promise, and being able to automate a lot of stuff that's been doing by hand. So that's very, very exciting. I think that you got to work on that with them. So that's super cool, man.
Yeah, so that was cool. The other thing, though, I found very, very interesting, and I'm going to have to give a shout out to Drew Baggin. He's with the Loctite Henkel Group. And, I have always said that I will never use resin for orthotics prosthetics. And he made me eat my words because they released a new, I don't even know, it's an elastomer. It acts a lot like TPU, but it's a MedFlex one.
I looked at that too. Yeah. Okay. Yeah.
They talked me into making a file for them. I made it. I actually put it on the patient, and this patient has been an amputee forever, for her whole life. And she said it was the most comfortable thing she's ever worn. And
I think that's cool.
So
man,
that means
I think these resins. First off, I think we could do a whole episode. We maybe should about these resins because, if you're going to process them, or if you're going to have people working for you to process them, you need to kind of know your thing, because like a lot can go wrong. The skin sensitization. Oh my goodness. And for your employees, also, if you don't cure it properly, if you don't do that kind of procedure, then there might be issues for your client. So, and these guys, the other thing is these things it's a thermoset, right? So it tends to break. If it breaks catastrophically, kind of like glass, So that also not wonderful, I think. But these things are getting better. Like the double cure ones are getting better all the time. And a lot of interest from shoe companies is spurring a lot of innovation here. And there's some problem with shear stress, fatigue, lifetime, holding up against certain solvents or creams that you might use and things like that. There are some issues there, but I do think, I do think that for a lot of stuff, and maybe mechanical small stuff, I think we could start to consider this stuff. And for this liner type of application with high rebound and very, very high degree of softness, as coupled with the right lattice structures, this could actually be a really cool solution.
Yeah, I mean, and it appears to be very durable. It went right against the patient's skin, and there's no other way to describe it other than memory foam. Like it feels like memory foam, and the lattice just it was true to the way it was designed. So a lot of times, I design and I love it with MultiJet Fusion and either a BASF TPU or a Lubrizol TPU. But once you smooth it, you lose some of the detail of the lattice and that sort of thing. And with this, it is the way that I built it, and it was amazing. So there's definitely something there. I don't know what it is, but it's something that I want to explore. I'm not saying that I'm lining up to buy a resin printer right now. I can tell you that.
No, I think it's good. I think, and also it's important before people start like using their Frozons and stuff that that the Henkel's one of the few players that are actually working on skin contact approval, medical device regulation approval, resins and stuff like this. And you have to follow the procedure correctly with curing it, washing it, all the stuff for it to actually work. And otherwise, that's your responsibility. So, and that's a bit different, I think, than fishing it out of like a bunch of powder. You know what I mean? So it's a bit more of the onus is much more on the producer here. I'm not trying to I'm not anti-resin, right? But I do think you need to be a little bit more, like, for example, a friend of mine asked for some printer advice. I told him, 13-year-old kid, I told him not to get a resin printer, whereas I told him, get a Bamboo Labs or a Prusa Research printer, and that'll be, totally fine in the house, So there's just a little bit more risk with these things. But I think, you're right. What Henkel's doing is really awesome. And they have a sterilizable resin as well, and they have this soft elastomeric resin as well. And I think it's really very, very exciting.
Yeah, well, what's interesting, and so the reason why, and it's really has stemmed from the discussion that you and I had with Jacob, who we had on the show, who does a lot of resin printing, and it really stemmed around this whole idea of how important PPE is when you're dealing with resin printers. And I'm like, I'm really not interested in all that. But what Henkel and Loctite are doing is they're getting rid of all that stuff. They have reformulated a lot of their stuff, and they've even, if you want to clean it or whatever you do to wash it, they have their own material for that is not as bad for you as the other stuff. So like they've invested in this formulation that's less bad for you. I can't say that it's not bad, but I don't know enough about it, but enough to where the only thing that's on the bottle, instead of like skull and crossbones and a whole bunch of other things, is the hazard sign with an exclamation point, which I believe just means that if it's in an uncured state, you do have to throw it out with hazard material. But if it's cured, there's no issue. So I that kind of changed my perspective on what I'm interested in getting involved in, and definitely that company. And it sounds like you're high on that company too. They're doing it in a more responsible way and kind of leading the way with the resin. So
I've gone there, like, for example, with the client, and they had a high volume application, like a medical device application. And you know what was really refreshing? They kept saying no. You know what I mean? And that made me very, very happy. They were like, well, no, or if only in this case, And I like that, because like we have too many people in 3D printing that have this like kind of gumption go thing. And if I want an implantable medical device, I don't want go. I want you to be very, very careful and very, very. There is no undo, right? I mean, so I like that about them. I think that they're very kind of careful. So yeah, I agree. I think it's a wonderful thing to have in our industry.
Okay. And the other thing that was a hit is I 3D printed some glasses on the MultiJet Fusion 580, and they're real glasses. I wear glasses all the time, and so I put this wood grain on the glasses, and it was funny. I was actually at the HP booth, and somebody goes, "Oh, those are nice glasses. Are they wood?" And I go, "No." I'm like, "They're made out of HP." And they could not believe it, and I think that's one thing that I'm proud of. What our team does is we at Advanced 3D are really good at color. Like, we make stuff good. It looks good on the back end as well. And I even ran into some optical guys that couldn't believe that these were 3D printed. They didn't even know you could print in color. And so that's going to be interesting. And I know you have always said, and I don't know much about it, is really eyewear is a new frontier for 3D printing.
Yeah, totally. I mean, eyewear is a really, really really amazing application. Like one of it is like, yes, you can get custom fit eyewear. It's really funny. It's the first thing that time my girlfriend says, like, but I've never had a pair of glasses that didn't fit. You know what I mean? So it's like yes, we can customize them, but that's not exactly the problem for most people. You could get something that fits your face a little bit better. But the real issue is that you can produce on demand. And eyewear is a really strange market where they destroy a lot of stuff every year, and they do a lot of stuff heavy discounts, because it's very style dependent. A lot of fickle kind of consumers. It's very kind of like you buy sunglasses in the summer. You're not going to all of a sudden buy. Well, most people wouldn't then buy another pair of sunglasses, next December or something. So it's a very kind of rapidly moving market, and they end up destroying a lot of products. So making on demand and making close to the style and close to the customer means it's a really good application. And at the same time, it doesn't use a lot of material. They fit in the printer really well, and they tend to finish really well. And there's a couple of people doing this at a relative scale, some in resin, but mostly in PA11, PA12 with powder bed diffusion, some with MJF now. And it's a really beautiful application. It's a difficult market to get into because it's so style dependent, but once you're there, we can get cost competitive. We can make cost competitive glasses. Now, one-on-one maybe will be more expensive, but on the whole, you don't have to order 100,000 of these things in Italy and then wait 6 weeks and then discount half of them and then give away a quarter of them or destroy them. So the economics are there for glasses.
Yeah, so I think that was crazy, and Loctite's actually leading the way with some resins for eyewear too. So I mean, it was really neat to see.
Cool. And were there any new machines or things where you were a little bit tempted by, or you thought were really cool?
Well, I mean, I think that there's a couple metal machines. I was talking about PPE, and I do like some of these metal machines that are all in one. So like the one-click metal machine, it looks very, very cool, and it seems to be fairly self-contained to where you are definitely safer when handling the metal stuff. The stuff's expensive. The metal stuff's expensive. It's interesting to me, but I have heard like, how do you make one metal machine go? You have to have two or three, so because one's going to be failing while your other one is printing.
But also the economics of this. If you want to like an M290 or something like this is the kind of the mainstays of the industry. Actually, I would always tell people to get two. Also, the economics of your operator, right? You have one operator spread out for two machines. Also, the flexibility it gives you with builds, and it also allows you to reuse some of your finishing equipment stuff. So typically, it's very difficult to impossible to make money off of one metal machine, and then you need two or three, and a bunch of post processing stuff as well. So the investment is like you're talking like $3 to $5 million usually for you to go anywhere, right? And it takes you about 6 to 8 months to learn how to ride, learn how to do this. And we're not talking like aircraft parts, right? We're talking about like something, more or less the right size, let's say.
Right.
Not like we're talking like something for a satellite, but it is there. But one of a few options you do have is one-click metal, which is like you don't have the powder there. It's cheap. You don't require extra gas stuff and all this. So it's a very affordable machine and very interesting thing to look at. And there's Alpha Laser as well. There's some cheaper Chinese machines coming along. There's Exact Metal. There's other players in that space. But you're right. The one-click metal, like, and they went really far in trying to make it less dangerous with powder that can explode and stuff like that. So I think that's a really exciting option. Just how many more people can afford to invest like $200,000 to get into metal as opposed to having to invest $5 million. That's like the amount of businesses that have $200K lying around as opposed to those have $5 million lying around. That's a lot. That's like hundreds of thousands of more businesses. So I think that's really exciting.
Yeah. And I would say lastly, it was super cool. Chris Baschuk from Point Design. So we've had him on and Levin on. The fingers, the partial fingers. They won an award at Rapid for the shoulder socket. It's the one that he placed also first at AMUG in the technical competition. So it was really cool to see him and his team get that. And I mean, they're just doing amazing stuff over there. So super proud of seeing that and the award going to somebody in O&P. I mean, that was really cool.
That's nice.
Yeah.
Cool, man. All right, so we have a guest, long-suffering guest, poor guest. But we should get back to it after telling you that this show is brought to you by Advanced 3D. And that is a 3D printing production company, your partner in design, production, and fulfillment of 3D printed goods for orthotics and prosthetics. So if you want a 3D partner to do anything from getting a file designed to getting something invented and made or doing serial production, then you can talk to Brent and his friends at Advanced 3D. But anyway, so we have a long-suffering guest, the most patient guest in the whole world. Who is it?
Well, I'm really excited to introduce you to Katie Richmond. She is a prosthetist and orthotist and a designer for Advanced 3D. And so we had been talking for a long time, and I've seen what she is able to do and was able to do with her previous job. Mm-hmm. And I was like, wow, she was one of the first people that I really thought got not only the clinical side, mm-hmm. but then also the design side and where the advantages of additive manufacturing came into play. And so, I'm really looking forward to hearing her journey. I don't know that I've heard the whole thing, definitely bits and pieces. And but I'm super excited to have her on board at Advanced 3D. And she has been helping us a lot. And on some of the stuff that you're passionate about, productization, automation. I know, and you have always told me, Brent, there's got to be a way mm-hmm. to automate this, make it faster, make it more accessible to people. Mm-hmm. And she's definitely leading the charge of that for us.
Okay, awesome. Congratulations. Hey, welcome to the show, Katie.
Thank you.
So first off, how did you get involved in O&P?
So I was born and raised in Indianapolis, Indiana. From the time that I got an American Girl doll, I always was asking for ace wraps and was making splints for my American Girl doll, to the point that I had to get the one set that they sell that has crutches and a cast. I got the one where it's a wheelchair for your doll. So I've always been interested in it. I did not realize it wouldn't be until high school that I figured out that this was a full-on career. And I am a huge fan of the Olympics. I realize sometimes there's good and bad and ugly and all of that, but I was able to go to the 1996 Olympics as a 7-year-old. My parents took myself and my sister, and it was an incredible event that I really became passionate about and kept following. And then when you want to make braces for your dolls and you love the Olympics, at some point they crash together, and I learned about the Paralympics, and I said, whoa, I'm about that. So back in the day, before they had any televised coverage of the Paralympics, you could go on to YouTube and they had the daily recap. They showed the best of, who won medals in what event, all that. So I was watching that, and it was the summer between my junior and senior year in high school. And the little bar on the right-hand screen of YouTube that suggests what you should watch next had a 10-minute video from, I believe it was the Academy, that was describing what a career in O&P looked like. And I distinctly remember watching it through twice and then going downstairs to find my mom in her garden and said, you have to come up here and watch this, because this is what I'm going to do with my life. And so that would have made me 17 at the time, 18. And I haven't looked back since.
That's cool. That's cool. And your education path in, like, what did you end up doing first then, education wise, and later on?
Yeah, that was also pretty easy because I knew where I wanted to end up. At the time, did not realize it was going to be a master's. I was the first year that was required, so I thought I was going to be able to sneak in with a certificate, but my undergrad is in kinesiology, emphasis in sports medicine from DePaul University in Greencastle, Indiana. And then I went on to University of Pittsburgh for my O&P master's degree. And honestly, kinesiology prepared me so much. I had a lot of classmates who struggled the first semester with some of the, like, before we got into the O&P stuff, biomechanics, just how we move. And I thought it was pretty easy. Not everything, but, being well-versed in that helped me blow through that first semester.
So I'm going to go out on a limb here, Katie, and say that someone is operating a drill or a kind of belt sander.
I'm getting a new HVAC system. So in addition, you're probably going to start hearing a puppy bark when she's ready to get out of her crate. So nope, you are correct. Okay.
Congratulations on a new HVAC in time for summer. Very good purchase, I would think.
Yep, a hefty one.
Very timely. Okay. Let me know. I hope Brenda will manage to edit out. If we don't, then everybody understands why. Okay. So, and when? How about the 3D printing stuff? When did that first? When did you first start to grapple with that?
I mean, I've always thought it was cool. I'd say probably 2020. One of my friends got a little tabletop. The print volume's maybe 5 inches. No, maybe 4 inches by 4 inches. And that had me like, oh, what could I print in there? So I hopped on and did a little bit of online designing just to see what I could do. And what was that? September of 2022, I was kind of charged with a research project that involved device development. And in taking out human error, I took a product that was conceived and attempted to modularize it, if that's a word, so that it could be put together in a way that was foolproof. Because for those who know, the example is if you try and bend a pair of uprights for like aluminum knee joints, you need somebody who's really good at that. But once you bend them, do you want to bend them again in case it breaks? No. That in order to reuse things and make it so that it was efficient, I needed to take out our human error part. So to do that, it seemed like, hey, it would make this a lot easier, CAD. And that really, once I started doing it for that, I saw what it could do and then had to start designing for some of my patients after I knew what was possible. And Brent helped me out with that.
Oh, that's cool. And now, do you spend most of your time designing, like career-wise? Are you designing most of the time, or what are you doing most days?
I am designing every day, all day.
Okay, super cool. And what's your workflow design-wise? What tools do you use from, let's say, idea to finished product?
Well, kind of depends. We have O&P partners with Advanced 3D who send us scans. And I'll tell you right now, as things move forward and digital workflows become more commonplace, the quality of a scanner is very important. because we get some scans from some companies that use great scanners and it's easy. You see all the detail, and then others you're like, it was more of a ballpark situation. So get a raw scan. I am mostly working within freeform now. I did not have that until starting to work with Brent. It makes my life incredibly easy compared to some free software I was using before. But I also enjoy parametric modeling and reverse engineering, and I mostly use Fusion 360 for that. But I was teaching myself that before I met Brent. So it was something I felt comfortable with. I'm sure there's other good ones, but that's what I've been using.
Would you recommend to someone who's like, maybe I don't know anything, right? Would you say, hey, you need to, understand one CAD thing first? Or would you say shop around, or you should have 2 to 3 things in your arsenal? What's your strategy for learning this whole CAD thing?
Well, I can only speak for myself, but if you had to learn one before you learn another one, I would still be on my first one. I constantly am learning new tools and ways of doing things in every software. I started with Mesh Mixer. It's incredibly powerful despite being a little janky at time and crashing my computer, but I would highly recommend getting that, playing around with it. And the free Fusion 360, you can do a lot with the free version. I liked both of those, and that's where I would recommend to start.
And how about designing for 3D printing? I mean, I think, do you jump in there? Do you start with something easy? How would you advise people to kind of come to grips with that?
It depends. What are we printing? How are we printing? Because that was another thing. I have a Bamboo Lab Carbon X1 that I absolutely adore. And I mean, I make stuff for my house, and I've even made some partial hands for some patients. But it really just depends on knowing where you're headed, and if you're headed to an FDM machine. Mm-hmm. I gotta get a nice flat base so I can anchor it to the plate. I have overhang, all of that. And it is a very fun new playground to design, not totally, but essentially with gravity removed, and being able to use MJF.
Okay. And then, I think the first entry point for most people is likely to be FDM, material extrusion type of stuff. So big flat build plate. That's nice. Rounded edges. Yes, no, maybe. So some more things you think people should look out for if you're doing FDM.
I mean, I feel like I've been doing this for over a year, maybe 2.5 years. Not with Brent, but playing around myself. And I still will print things and be like, well, that wasn't the smartest way. I should have done that. So I don't know that I have any sage, like, ta-da, save yourself from this error advice, other than be prepared to fail. And then use that to figure out what you do next.
Totally. And I have the Bamboo Labs Carbon at home as well. Same printer. I love it. Is there anything else you've used before or you would also recommend? Or would you just say to somebody, like, just get a Bamboo Labs? Is that the current state of things?
I mean, yeah, right now I would, for sure. When I first started, they had not come out yet. It was like right before. I think did they do a Kickstarter or some sort of funding?
Yeah.
Point is,
they didn't need to, but
I was not ready to. It was my first one. I was looking for more in the hundreds of dollars range, not $1,500. So I got an Anycubic Cobra Go or Cobra tiny build volume, and I worked that thing to death. And I used that for about 6 months, and it was great. But now Bamboo has one that probably haven't tried it, but probably is better, and it's as cheap. So I'd probably just say do that.
Yeah, it used to be when people would ask me like what printers to buy, I'd be like, if she's left-handed, then you get, and it was really complicated. Now it's just like get a Bamboo Labs and then either get the expensive one or get the cheapest one, and then it's okay, So it's insane what they've done to our industry. I think difference for consumers and stuff, and they've just made everybody work harder. So that's actually going to be good. But I think these other players are not going to be super happy with them. And how about like filament wise? Do you use like one filament, lots and lots of different styles? What are you doing?
I really am only doing PETG, PLA, and TPU. I have this is my basement life, and I do not need any toxic chemicals or needing a ventilation system, anything like that. Because I know it's all set up to be able to do that with the Bamboo Carbon X1 and getting a filter, but I'm like, nah, I don't need that in my life.
Now you're doing MJF. Does a lot change there? Is that very exciting to you right now to look at, like you said, more design freedom?
Yes. I am going to botch this metaphor, but Brent has heard me botch it 1,000 times. So I really feel, I felt this before I joined the Advanced 3D team, but I didn't know you could get more into it, but you can. It just keeps snowballing. In the Matrix, when Morpheus is like, do you want to take the pill that makes you see everything or stay the same? I took the pill where you see everything, and I can't unsee it, and I don't want to go back. And now it's pretty crazy, but especially with Brent's encouragement and his attitude of wanting to find out the answer, not how is this going to be morphed into something that we can make tons of money off of. No, it's like, I need to know the answer because I want to know the answer. I feel like we can almost do anything. I realize that sounds maybe crazy, but no, it's pretty incredible.
I think that's one of the things that I really appreciated having Katie come on board is like, not only the experience, but like where she seeks kind of inspiration. So like I'm not an Instagram user. She is, so she'll be taking screenshots and that sort of thing. And then she lives and dies by this like journal, and she's a really good sketch person. And so like she'll have shapes and different things that she may want to try or what have you. And then we have these, the ability to get this stuff printed. So not only can you go from this concept to the design in the final material that you're looking at doing, and you can say, hey, we're going to take some of this that we like, but now, we thought it was going to work this way, but it didn't. And how do we change the geometry proportionally to that? So I think that's one of the neat things is that Katie is opposite of me in that I don't write a lot down, probably too much I keep in my head. And she writes a lot of stuff down, catalogs it. And that's part of the stuff that you have always said to me, Joris, is, hey, you've got to know, what you're doing, exactly what you're doing. And that's how you create a process. That's how you create an asset as well. And I think we have definitely been moving in that direction. And a lot of that is thanks to the way Katie thinks and documents.
The other thing, yours, that my first job in O&P was at the time it was called the Brace Shop, which was inside Riley Children's Hospital. Before they sold to an outside contractor, they used to actually, you were employed by Riley. So I did one summer there as a volunteer, one summer as an intern, and then the next 2 summers, they created a paid technician job for me. So I have a lot of hands-on. I've never not modified my own sockets. There was a period at one of my jobs 5-6 years ago where we didn't have a technician, and every single thing that I put on a patient, I had made myself, from a Vivac check socket to the final laminations. I got really familiar and was helping everybody else with their Click Medical, how to do the panels. And I think that I could not do what I'm doing now if I didn't have an idea of how it would be done if 3D printing was not an option. And it is in knowing how I would do it that makes me realize, oh gosh, wouldn't it be nice if you didn't have to worry about blank? And if that is taken care of through CAD or 3D printing, then it's really easy, or to me, it stands out and it's like, oh, that's where we need to change.
In your day-to-day work life, how does 3D printing actually help you?
Well, just to be, I wouldn't have a job right now if I didn't have advanced 3D. So, it helps me a lot in that sense. I think as a prosthetist, I have a lot more years as a prosthetist than I have experience as an orthotist. So I speak mostly to that. I mean, it helps me. It kind of is the same answer as previously. Like I drank the Kool-Aid, I ate the pill. If you come to me and you're like, this is a problem, I'm like, cool. Well, let's just try and fix the problem. And this is one more tool that I have that allows me to be like, yeah, you don't need to settle for that problem. We'll fix it. I don't know how, I don't know when. It might take 10 iterations, but like, I'm not going to quit.
And are you looking at any more new technologies, new materials? What are you looking for on the for new 3D printing things?
I mean, I'm along for the ride, and I have the benefit of getting to talk to Brent at least 5 days a week. So he is definitely pulling me along with them.
So like on the 3D printing side of things, let's say for patients and such, where have you seen obviously we can make something different, but like a different outcome, right? Is it, can the patients actually tell, or do you have a specific story about a patient that had something 3D printed that, could otherwise not be done or not be done as well or what have you?
Yeah. The big one that, my fellow clinician at the office I worked at previous with was, I loved working with him very much along the lines of, who cares if it's hard? We're gonna do it anyway, or at least we're gonna try. And what really got me doing with you, Brent, was printing in TPU for distal cups for double-walled sockets. And the reason that 3D printing seemed like the easy decision was in talking to our central fab. I mean, they hated those. In it was built in to the cost that they would charge us, a cost of an extra sealing sleeve because they were going to put one on and then cut it off with the lamination. They actually anticipated having to restart once every single socket they did, like totally scratch it because something leaked. And I think when I started, they were like, yeah, that'd be a 4-week turnaround. I'm like, no, that's not okay. And I didn't have a lab. And honestly, I probably would have gone in and showed them how I would have done it. But it's really nice to be able to, for me, I have trouble letting other people do what I know how and know exactly what I want to do. But with CAD, I don't need a giant lamination room or grinder or anything like that. I can make it exactly what I want and know that it will be that when it comes out of the printer. And I definitely had that experience with the double walled sockets, and just started to dip into latticing before I stepped out of that job and joined Brent at Advanced 3D. So I'm looking forward to, in the future, being able to be seeing patients while working alongside Brent.
So you mentioned the lattice side of things. What are some of the challenges? And then, and you can kind of speak in kind of generic terms, like what are some of the things that you do for lattice structures, or where are you seeing it be the advantage for patients? And then you can talk about some of the difficulties in designing lattice structures too, specifically for O&P.
Yeah. I mean, the easiest one is weight. I mean, the materials we're working with are already light, and then you remove excessive and it's great. The other thing is the cushion, and under your direction, I've played around with, the beam radii and the inner beam versus the outer beam. It's still clear as mud to me, but I used to do some, I liked Excel for my inner flexibles. I liked working with it. And I would do like pads on the outside before I did a lamination, essentially building in an area of cushion, but allowing for total contact and, still being able to achieve suction. And this is the easy way of doing that, because again, trying to explain to someone possibly in a different state than you, if you're using a CFAB, when I was not able to have my hands on the model and laminate it myself and create that pad in the way that I knew I wanted it, that was difficult. But in 3D, with latticing, I can put things exactly where I want them to be.
Well, I mean, I think one of the cool things about the lattice structures is, so there's a few things that we have to consider when making these. One is the material. What material are we going to do? How are we going to post process? Are we going to smooth these? And then does the lattice structure go all the way through? So one of the things that we look at doing is creating a membrane structure on the inside that's very thin, but then but it needs to be thick enough to smooth. And then your beam size needs to also be wide enough, or your cell size needs to be wide enough so the smoothing can go all the way in and smooth on the other side of the membrane. And so it ends up being a pretty technical issue. And I think, especially with Katie's help, we have been able to start characterizing some of these lattice structures to the point of production, rather than, hey, this feels pretty good. Now we're at, this feels pretty good, and we can get repeatable results, and we can turn that into an automated process. And if we need tweaks here and there. So I think that's one thing when people are looking at lattice structures, it's one thing that it looks good, feels good. And then there's another thing that, can you do that a second time? And that is super important, is the ability to be able to characterize it and be able to do it a second time and repeat it thereafter and understand why it's doing it. So I think that's pretty interesting.
I feel like I'm still, maybe not daily, but almost sometimes, I feel like I'm learning new ways to use programs I have had or just got access to like, it's just so much is out there that, to me, yeah, of course I want more things, but have I completely searched what's out there? Trying, but it is a never-ending job, and just kind of being aware. And, Brent and I have talked about LinkedIn is great. I use Instagram, and, that is a way for me to see things that I didn't know were possible. So I might wish for it, but what if it's already out there?
So do you think having a small printer in-house is worthwhile? Is that a place to start?
The benefit of having a small bamboo-like printer in an area where you don't have access to big fabrication, to do a custom wrist hand orthosis is nothing. I like the idea of having it be more involved from the beginning in the process. I myself, because I love prototyping, you shouldn't have to need a $500,000 printer. You get yourself a Bamboo Lab printer and you start messing around with it, and it's like, oh yeah, no, of course, for that partial hand, why wouldn't we do a check socket? It takes a couple hours to print, and you get to try it on, and the cost is barely anything. So upper extremity, both orthotically and prosthetically, and pediatrics, all of it. It's just about getting it. I'm torn because the barrier to entry is high. And there's a fine line between automating things to the point where the practitioner just plug and plays on the iPad and doing all the design themselves. And I think it depends. I'm idealistic and I want to do everything myself. So I don't want things to become so easy that it's like, here, this is by numbers, just throw it on, it's good. But maybe we can get it to be that good.
Okay. Do you think we are at the point where 3D printing has to be top of mind for clinicians and practices?
I guess it depends. I think that it is not optional in the sense that anymore, it feels like it would not be smart to at least dip your toes in to scanning. And if you have zero intention of making definitive MJF sockets, you should still probably be printing, even if it's only BK sockets. Like, oh, I don't want something that's so big that I could do 8Ks. I think it would be stupid to not, because the other thing that worries me is, by the time some of the big players in 3D printing and O&P, by the time they get to be so good and things are made pretty easy where the clinician doesn't need to really know the printing techniques as much, I don't know. It's a fine line.
Well, but I do think, to your point, though, it being a fine line, I think it definitely needs to be a tool in everybody's toolbox. So I think the other part of all this is there is times to use traditional fabrication.
100%.
But if you are only limited to what is available in traditional fabrication and you have completely closed off the 3D printing side of things, you're not doing right by your patient. And I'll die on that sword. Like, you should try to make every tool available in your toolbox. And if you take a part off that potentially can help your patient, to me, that's a problem.
It does depend on the clinician, on how much they want to be involved. But I think you're going to get outstripped in your field if you are not at least okay scanning and being open to these things, because now with social media, patients are going to come in and be like, well, why can they do that? And can I get that from here? And if you say no, then they'll just go find someone else, as they should. As much as they are patients, they are consumers, and they're the ones that need to be happy. So if this is part of it, I think you should definitely jump on board.
Katie, thanks so much for being here and for the discussion. This was really great.
Of course. Thank you.
Brent, of course, thank you for being here as always.
Oh, this was cool. And Katie, it was good hearing the story. I did not realize the one about the dolls. I knew a little bit about the Paralympic stuff, but kind of that where everything kind of collided for you.
Yeah, and yours, things will collide again, because I am living out a lifelong dream, and my husband and I will be going to the Paris Paralympics this year. So we are psyched. Mostly me, but he too is okay with France.
That is so cool, Katie. Best of luck to you. And thank you, our listeners, for listening. This is another episode of the Prosthetics and Orthotics Podcast. Have a great day.
And that wraps up another episode of the Prosthetics and Orthotics Podcast. A big thank you to Katie for sharing her expertise and insights today. If you enjoyed today's episode, make sure you hit the subscribe button so you never miss out on future episodes. Thank you for listening, and we'll catch you next time on the Prosthetics and Orthotics Podcast.